Welcome to the channel.
The problem is, assuming VC saturation is equal to 0.3 volt for a silicon transistor at ambient temperature of 25 degrees Celsius and HFE is equal to 50. The minimum base current IB required to drive the transistor into saturation for the circuit shown is. In the circuit, few things are given. I am drawing the same circuit. Say this is VCC, which is equal to 5 volt. Then I mention this is RC, this is equal to 1 kilo. This is transistor. Say Q transistor. Input resistor. We have to find out this IB current. So what is given in the problem? This VCE voltage is given, which is equal to 0.3 volt. So VCE saturation is given, that is 0.3 volt. The current gain, HFE is the current gain, which means beta value, which is equal to 50. Let's start the solution. You have to find out voltage across resistor. Here I am applying simply KVL. This is plus VCC, which means this is positive, which means this is negative and this is positive. Then RC, we have to find out the voltage across RC. This is transistor. The voltage between the terminals collector and emitter, that is nothing but VCE saturation, which is given 0.3 volt. So I am going to assign the terminals positive, negative, say positive, negative, and then apply KVL like this. So what I am getting, VCC, if you go from left to right, the sign is positive. So VCC going ahead from plus to negative at RC. So this is minus. IC current is flowing through this branch. IC, RC, then again plus minus going ahead in the calculation. The first terminal is positive, second one is negative. So we have to consider the second terminal again negative, VCE, which is equal to 0. Now we have to find out IC value. So accordingly we are arranging the equation. So what we are getting, VCC minus VCE, and changing the side of IC RC. So we are getting positive IC RC. Now what we are getting, IC is equal to VCC minus VCE by RC. We know the values of VCC, which is 5 volt, VCE saturation given 0.3 volt, and RC is also given, that is 1K, means 1000. So what we are getting, IC is equal to 5 minus 0.3 means 4.7. And these 3 zeros we can write in this way, 10 raised to minus 3 ampere. Then what we are getting, IC is equal to 4.7 milliampere. In the next calculation, we know the formula, that is IC is equal to beta IB. So beta is the current gain. So what we are getting, IC is equal to beta IB. So what I am writing, we have to find out IB. So write down the equation, IB is equal to IC by beta. We know the value of IC, 4.7 milliampere divided by 50. So what IB we are getting after solving this, IB is equal to 0.094 milliampere. So we can convert it into microampere. So IB is equal to 94 microampere. So IB value is 94 microampere. In this problem, we are getting the option C is right, 94 microampere. So in this problem, option C is right for the given problem. This is the solution of this problem. Thank you.